Hello, hello. Give me a few minutes to let everybody into the room. Thank you for your patience. It was taking quite some time to download the lesson, the recorded lesson that we just did before this class. But give me a second to let everybody in. All right, cool. Okay, I think there'll be more people coming. But here is the attendance for today's class, and make sure that you don't leave until you're told to do so. All right. Yeah, so this is attendance. And for today and on Thursday, Miss Mac won't be here, and it's going to be me taking over class. All right, so the national holiday today is, let me see, it's the Lima Bean Respect Day. I don't know if it's a popular vegetable, but from what I've heard, it's an okay vegetable. So the question for today is, what's one food you used to hate but you actually like now? For me, I used to really dislike eggplants, but somehow after going to college, everything kind of changed for me. Squash, yeah. Cool. Thank you for the attendance, by the way. Onions, yes. We have onions from previous class too. Yeah, people don't usually like onions. Great. Yeah. Have more people share in the chat. How did you know? Yes, Diana, it was Chelsea. You were right. It's awesome. Great. Okay. Oh, I see. I'll let her know on Thursday too. Yeah, let me take a screenshot of this. I think it's kind of funny. Cool. All right. So thank you for sharing what your vegetable or food is. All right. Okay. Before we start today, I'm actually gonna give you guys a poll. Right. I'm gonna set the poll, and you're gonna tell me whether you've done the note or not. Let's see, done with notes or not. I'm just gonna launch it right now. Cool. All right. Awesome. So for those of you who have done the notes, I know that Miss Mac usually opens the breakout room for you guys. Let me see. Oh my goodness. All right, let me see if I can open the breakout rooms for you guys from here. Let me stop share for a minute. Cool. So let's take a few minutes to answer the poll before I open the breakout rooms. For those of us who just came in, here is the attendance. Take a few minutes to do the poll. All right. Okay, so it seems like a good number of us have done the notes. So I'm just gonna open the breakout room. So if you wanna work with your peers, that's awesome. If not, you can stay in this room with me and we can work on the notes together and we can work on the assignments also. All right, I'm just gonna get the breakout rooms opened and started. All right, so those of us who have done the notes, feel free to join breakout rooms. And those of us who actually completed the assignments, which is great, you're free to sign off after getting your attendance. All right, I'm gonna give one. Actually, I think everybody answered the poll, which is great. All right, so if you want to go to your breakout room, feel free to do so. If not, I'm gonna be sharing my screen and working on the notes together. Okay, just give me one more second to get everything sorted. Give me a second. And let me know when you are ready. If you're ready, please type a Y in the chat. And I know that I can start the session. If you're ready for a note taking, please give me a Y in the chat. Bye, Antoine. All right. Cool. Okay, let me share my screen. Yes, Amy. Give me a second. This is the link. Awesome. All right, for those of us, Diana, for those of us who are staying in the room to work on the assignments and the notes together, here we go. All right. So today we are doing sketching polynomials. This is Notes 36. All right. So here we have steps on our left side. And I know that we have a lot of words in this. Benjamin. So here is the attendance, Benjamin. So what you want to have for sure is this box. You want to have this box. You want to have this function written down. And you want to have this graph drawn out. Okay. So the first thing we're going to look at is to find the solutions. Can someone tell me how I can find the solutions using this equation? Y equals x plus 3 times x plus 4 times x minus 2. How do I find the solution? Or if you prefer the term finding zeros, how do I do that? Cool. Yeah, because you have those numbers, all we have to do is to flip the sign in front of it. So we'll have, when it's a positive 3, we will flip it and becomes a negative 3. And when it's positive 4, we flip it, becoming negative 4. And when negative 2, we flip it, it becomes positive 2. And that's all we have to write. So that's finding the solution. Okay. And the next part is to count how many solutions there are. And we can do that by counting the exponents, right? So when there is nothing written for exponent, it's an automatic 1, right? Because anything to the square root of 1 is just itself. So we have 3 ones. All we have to do is add them together. 1 plus 1 plus 1 is 3. So we have 3 solutions, which is x cubed. And remember on last Tuesday, we talked about the shape of polynomials, right? And x cubed will look like this for if it's positive, and this if negative. So this corresponds to the step 2 of our note. So if you download your notes today, you won't have step 2. This part is actually canceled for you guys. But for my version, it's an older version, we have step 2. And then following that is the third part. Because it is blank, it ends going blank. So in this blank, we only have 2 options. It's either a positive or a negative. And to do so is we look at the sign in front of our overall function. So in this case, it's empty, meaning that it's positive. Positive is the default sign if there is nothing written, right? Because it is positive, it ends up going up. And we're going to see an example where it's negative real soon. But for those of us who want to get ahead, if it's negative, If negative, it ends up going down. All right. And to know what the end up do, this ends up is you want to look at the most far right point. To do so. Okay, that's awesome. All right, so let's actually plot the points. So we have -3, -4, and 2. So all we have to do is to plot these points. 1, 2, 3, and -3, and -4, and at 2, right? And the point to the most far right is at 2, right? So we know that at this point, we're gonna end up going, let me see, we're gonna end up going up because it's a positive function, right? So we're gonna end up going up. I'm just gonna draw like that. The second part to tell whether this graph looks like is to look at the multiplicity. And remember, to look at the multiplicity, you want to look at the exponent, right? When it is with an exponent of 1, it means that it's single root. So when it's single root, your line is just going to go through a point, right? We're going to have an example of a double root very soon. So we're going to see how it looks differently. So here I know that we're just going through the point. So we're not going to have a concave up or a concave down. So in this case, we're just going to have this line go through this point, right? And let's look at when x is at -3. Because it also only has an exponent of 1, I know that it is a single root. So at this point, it's also a single root. So I'm just going to draw out like a line. And we're going to connect the lines, these two lines. We're going to connect them. Our last point is when x is at -4. Because this x1 is also only 1, we know that it is a single root, meaning that the point goes through, right? It's not concaving up or down, it's going directly through. So this is the overall sketch of my graph. And remember that we're only doing the sketch, right? We're doing sketching polynomials. We're sketching it, we're not doing an accurate drawing. It's just a sketch. So that's the overall shape of this graph. So our graph looks something like this, right? And you see how this looks like this, which is how a cubic function is supposed to look like. So we know, hey, at least we have this general shape accurate, right? So that's how we do the first one. Does this make sense, Angela?
Yes.
Yeah. Did you work on the notes or are you just hanging around here?
Yeah, I worked on the notes.
You already looked at the notes?
Yeah.
Okay, so if you want to work on the assignment portion right now, we can do that. Or if you want to just sign off and do the assignment on your own, we can also do that.
Can we work on a couple of questions?
Yeah, of course. Yeah, I just don't want to waste your time if you already seen the notes. Which question would you want to look at?
Um, um, okay.
Yeah, for sure.
Can we work on, I guess, number 4?
Yeah, for sure. Okay, cool. So we have the function x plus 2 times x plus 1 squared, right? I guess our first thing is where are our zeros? How do we find the solutions?
Do we have to switch the signs?
Yeah, all we have to do is to switch the sign. So what should we get?
So we should get x -2 and then x -1. So the graph is most likely going to be negative.
Not exactly. Let's get to that next. All right. How do I note the square?
I'm
What
sorry
does what does the square tell me?
that there's two binomials.
True. Yeah. So there are two solutions, right? So this is we're gonna write m2. So it means that it's a double root. It's a double root, and we're gonna see why it's different from single root very shortly. So here we have single root at -2, right? Because there's nothing written here. It's an automatic one. So it's just gonna be a single root. And double root, it's gonna be when x is at -1, right? And what you mentioned about the sign, we actually find it here. So if the overall sign here, nothing is there, it means that it's a positive because positive is the default sign, right? So it means that we actually have a positive end. Does that part make sense?
Yeah.
Cool. All right, so let's try to plot this. We have a point at -2, and we have another point at -1. And we know that it's a positive, so what happens to the end? Does it go up or down?
It goes up.
Yeah, it goes up. Oh, it goes up at the end, right? And because we want to look at the most right point, we look at -1. So we know that it goes up. All right, the next point, no, you're fine. The next point is whether this -1 point is a double root or a single root. Do you remember the difference between double and single?
Um, double is no, I don't remember.
Yeah, for sure. So if it's a single root, right, we're gonna have a point. Oh, that is an ugly drawing. Let me get rid of this. So if it's a single root, it just means that the line directly goes through the point. Versus if it's a double root, it means that we either am at the valley, which is at the very bottom, or if we're at the hill, which is at the top, right? And that's how you tell if it's single or double. Does that explanation make sense?
Yeah,
What? Can you say that one more time?
it makes sense.
It makes sense? Cool.
Yeah.
Thank you. Yeah. So that's how I know. So because it has an exponent of 2, I know that I'm supposed to cave, right? I'm supposed to cave. Let me draw it a little bit smaller. So I'm supposed to have that. And let's look at when x is at -2. Is it a single or is it a double root?
It's a single.
That's awesome. And what happens in a single? Do I go through the point or do I curve up or down?
Go to the single point.
So you want to go through the point, right? So let's try to draw this. We have something that's going through. So let's just have it goes through the point, right? And all we have to do is to combine this part and that part. So we'll have this. We just combine it like that. So it looks something like this. Does this make sense?
Yeah.
And another thing is to check whether my graph makes sense is to look at what solution, how many solutions we have here, right? Do you know how to count the number of solutions?
Yeah.
Yeah, so we add the exponents, right? So we have 1 and 2, so we have 3 solutions. And remember last Tuesday, we were talking about the shape of the polynomials. So if it's x cubed, it's supposed to look like either this or this, right? And that kind of matches how our shape looks like. So that's how you solve this problem.
Oh, okay.
You want to take a few minutes to jot this?
I already have it.
What?
I already have it.
You already have it?
Yeah.
Okay. Do you want to work on another question then?
Yeah. Can we work on Desmos?
Oh, you want to work on Desmos? Sure. Let me stop share. Can you share your screen?
Yes.
You should be able to do so.
Yes,
Cool.
Yeah.
Awesome. All right, so here's an example. Y equals x times x minus 2 times x plus 1. Here, all right, so your single roots are just your solutions, right? So what do you have for your solutions?
Simple solutions is going to cut those two.
Mm-hmm.
And here we're going to cut -1.
Awesome. Last one could be a little bit tricky.
I think that person will put 1.
So
-1.
so it's actually 0, right? Because to find the solutions, all you're trying to do is to put a number that will give you a 0 for your y. So you got the 2 and -1, they're perfect. So any number times 0 is 0, right? That's why x will be 0 for one of the solutions. Does that make sense?
Yeah.
Cool. All right. The next question is it positive or negative? Remember, you're looking at the overall sign, and you can find that at the very beginning of our equation, right? Not the y, but right after the question mark. You see there's a space right after the question mark? Can you circle around the space right after the equation mark? Sorry. No, it's y equals, right? So your space should be right after the equal. Can your mouse go to where the equal is?
Yeah.
Yeah, so at this point. So it doesn't show anything. What does it tell me which sign it is? Is it positive or negative?
Positive.
Yeah, so can you put positive in the chat? So positive and then comma. The end goes up.
The n goes up.
Can you type that? The end. The end.
Oh, the n.
Yeah, sorry, I didn't enunciate it. The end goes up. Exactly. So remember, for plotting, you want to make a dot, a point for all the zeros. So you should have one at 0, one at 2, and one at -1. Awesome. Cool. And remember, because it's up, so the point to the far right will go up. So if you look at 2, it should go up, right? The end of when x equals 2. No, that's -1.
Oh.
All good. Cool. When x is at 2, you're still at -1. Can you go to the right? Yes. So you should draw out the going up part. Not directly up. Can you Control Z or Command Z?
Sorry.
No, you're fine.
I have a little bit of trouble.
It's fine. Okay, so the going up should look a little bit curvy.
So like this up?
The other way around. Remember when I drew it? It's the other way around, right?
I think I'm going to go back to
The notes. That's awesome.
yeah.
All right. I will also jot this down. So
I can't see it. Oh, so like this?
yes, 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 yes. Cool. Your arrow is a little big, but it's okay. I know it gets a little difficult to draw. All right. Okay. So that's how you know that it goes upward. And because we have single roots, right? Single roots means that we go through the point, right? So we don't do any concave. So you just want to go down a little bit, right? Okay. And then we're going to leave it at that. And we're going to look at 0 when x is 0. Because it's also a single root, we're just going to have a line going through, right? Not like that. Okay. You know what? Give me a second. Let me draw out this graph and I can share my screen with you so you can see what I'm doing. It's a little bit hard to go through decimals. That's why I thought it might be easier if we work on the paper questions, but it's up to you to do either decimals or paper. But let me draw out these points before I take over the sharing. X at 2, x at -1, and x at 2. All right, can I have you stop share?
Okay.
Thank you. All right, I'm gonna share real quick. Give me a second. All right, can you see my graph? It's not very straight. Can you see it?
Yeah.
Cool. So we have when x is at 2, right? So we know that it's going up. So I know that because it's a single root, we just have a point going up. We're not doing any concaves. It's not this, right? And we know that when x is 0, it's also a single root. So we have another line drawn here, right? And another reason why we're not going through this way, because we can make this. This is not okay. All I want to do is I want to connect this without adding any additional curves, right? We're just connecting the dot. And we also know that when x is at -1, it's also a single root. So I'm just going to draw a line going through the point, again, connecting the dot. So it looks something like that. Does that make sense?
Yeah.
Kind of, or do you have any like small questions that I can help answer?
And that all makes sense.
You sure?
Yeah.
Do you understand why we're not doing, like, you cannot draw a line through like this, right?
Yeah.
Because when you connect this, you're going to create this other curve, right? Which is like a no. We don't want to create any curve. All I want to do is to connect the lines, right? Okay, if that makes sense, I'm going to give back share screen.
Mm-hmm. Yeah. Yeah.
Cool.
How much time do you have?
We have until 3 p.m. So we have another 15 minutes or so.
Yeah, I'm trying to see which one's gonna be harder.
Angela, could you share your screen, please?
Yeah.
Thank you. Awesome. Can you draw what we just did? Oh, wait, did you finish that already?
Yeah.
Okay, cool. Awesome. Remember double, just you want to look at whatever there's like a square. Yeah. Awesome.
Two.
Great.
And since after this is a negative, so
Yes.
this time.
Negative. So is it going up or down? The end goes up or down?
The end goes down.
Yes. Perfect. Perfect. Okay, let's plot our points. Great. Awesome. And remember, our end goes down, right? You want to look at your most right point. So in this case, it should be at 2, right? X equals 2.
Yeah.
So it goes down.
So,
A little bit curvy downward. Perfect. Nice. Cool. All right, so when x equals 2, is this a single root or double root?
it's a single root.
All right, so are we going just straight through the point, or are we doing a curvy thing? A parabola thing?
A parabola.
Ooh, think again. It's a single, right?
Yeah, it's a single, so it's going to be a straight line.
Yes. Yes, yes, yes. So you just draw like a little line through that point. Oh, no, not that line. Remember? It's through the point. Remember how I just did it? I went through the point.
Oh, yeah. You went through.
Yeah. Oh, is this through the point? You're not going through the point. Through the point. If the point is here, If the point is here, you're going through the point. Right? It should be like that, through the point. Cool. Can you try to make it a little bit more straight so it looks a little bit more like that? I know, sorry, I didn't mean to be picky, but it might look a little bit confusing. You're still not going straight. You're going like vertical. We don't want vertical. I mean, we don't want horizontal. You want to go like this, right? It looks like this. Point, line. Okay, pause there, pause there, pause there. Great. All right, let's look at our next point, which is, oh no, you don't have to erase it. Our next point is when x is at -3, right? Is it a single root or double root?
That's a double.
Double root, so should it go through the point or is it like a parabola?
That's a parabola.
Awesome, so we're drawing a parabola, right? So how would you draw a parabola? Remember, in the end, you want to combine this point with the other point, right?
Yeah. Let's say that parabola. Or
all right, let me try to share my screen. I think you're a little bit confused. Don't stop share just yet. Okay, or don't stop share. I think we are slowly getting the idea, which is great. But let's just fine tune some of the things. Okay, let's see. We have a point at 2, and then another point at -3. 1, 2, 3. This is -3, and this is a double root, and this is single root. And we know it's negative, so we're supposed to go down. All right. Could you stop share?
yeah.
Thank you. All right. Okay. So this, can you see my screen?
Yeah.
Cool. So we have a going down, right? So this should be going down. Because it's a single root, we should just go through. You see how my line is much straighter? So
Yeah.
that's what you want to do. And then at -3, because it's supposed to be a double, oh my goodness. It's supposed to be a double root, right? Actually, let me do this. Because it's a double root, I'm going to draw this with an X. So I can tell that I need to have a parabola. Right, remember we need to connect this line with something here. So my line will probably look like something like this, maybe. Yeah, look like this, so we can combine this, right? And let's see how the other one would look like. If I have a concave that looks like this, right, I will create another parabola, which is not what we want. We don't want to create any new caves. So this is how our function looks like.
Okay.
Does this make sense? Is this
Yeah.
making sense?
So basically, whenever it's a single root, the graph is gonna look like on the right side, and whenever once double root, the graph is gonna look like it's on the left side of your picture.
Yeah, so if it's a double root, it's gonna be either concaving upward. Oh my god, that's kind of cool. Sorry. Or it's gonna look like this, right? So this is where our point is. And it's either gonna curve upward or curve downward, right? And in this case, we are curving upward because you remember how I showed you on the green? So if we have it this way, when connecting with this point, right? When connecting with this point, we will create another cave, which is not what we want. We don't want to create any new cave. So it's a little bit tricky to decide whether you're doing an upward cave or a downward cave. Does that make sense? A little bit tricky, right? But you got the idea. Yeah, so if it's double, it's like a curve, like a cave. If it's single, you're just going through the line, right? You want to go through the line. And you know how when you were drawing a little bit flat. If you draw too flat, it might be hard to determine when you want to connect this part and that part, right? So you want to make sure that, hey, if I know it's a single, you want to make sure at least like a big portion of your line that's really close to your point shows that it's going through. Okay?
Thanks.
Cool. All right, I'm going to stop share again, and you're going to show me your screen. And I think we have another 10 minutes. Yeah. Let's try to get as many problems as possible. Yes, looking pretty good. This is the example.
Okay, so for here, this is going to be positive 1, x is going to be negative 3, and this will be negative 4. And so
Is it 4 or negative 4? I think you type like
negative
equal.
4.
Yeah, for sure. All good. Oh, nice. Awesome.
That's just going to be positive.
Great. Great, great, great.
So the n is going up.
Yes, you got it. Let's go. Woo. All right. Next, plot your points. Yes. Ooh, wait. Remember, for the end, we want to look at which point? Most far right, most far left, or in the middle?
That's right.
Yeah. So can you try to sketch the up from there?
Yeah.
Yeah, that looks like a very good direction. Yes. Yes. Cool. Sounds good. Try to like extend a little bit more. I'm sorry, I'm not trying to be picky, but it will be helpful when we go through Thursday's lesson. Yes. Try to extend a little bit more, like just curve up a little bit. Yes. Yes. Very nice. All right. Cool. Okay, so if you look at 1, -3, and -4, they're all single roots, right? So what does it tell us? Is it caving or is it going directly through?
It's caving.
Okay, think again. So it's a single root, right? If it's single root, it should go directly through the point. You only cave if it's a double, right? When you have an exponent of 2, then you cave. So you want to start by completing our first point at 1. So it goes through, right? Can you draw like a line that extends through that point? Yes. Cool. It goes through the point. Yes, so close. Go through the point. Go through the point. A little bit, like not directly up, but through the point, right? At like a 45-degree angle. That's like a good way to look at it. Yeah. If you look up, go through a point at a 45-degree angle. 45.
It's 45.
45, remember? If it looks like this, 45 goes through like that, right? 45. Yes. All right, and then it's another single, so it should go through that point, right?
Yeah.
Yeah, oh my gosh, you got it. And then, yes, all you have to do, oh my gosh, yes. All right, extend. Finish this by extending. Yes, you got it.
Yeah.
Yes, that's it. Woo! Great.
Now I'm just going to count the slides on my hand. 1, 2, 3.
You don't count the first one, right? The first one is an example. This one, so you count from this one.
1, 2.
You don't count the examples. So 1, 2, 3. We just did 3 slides.
Here, just do 3 slides. Oh.
Right?
Here, I don't have to do. Oh, wait.
Yeah.
Did we do this?
No, they gave you the answer, right? This is an example. Yeah, so we only did 3 slides so far. All right. How many slides do you have to finish? Do you need to do 8 slides, or do you need to do 10 slides, or do you need to do the star slides?
I think 8 slides.
8 slides? All right, so if we finish this, we'll finish half of the slides. All right,
Yeah.
cool.
So
You
this
are
is
getting it.
thanks. And it was 2.
Yes,
It's to be a negative 1. It's
yes, yes.
going to be a positive again.
Woo. Breezing through. Let's go. Mm-hmm. Ding, ding, ding. Great. Yep. Yep.
Okay, so now I'm making this instead of cutting this one.
Yes. Great job. Oh, oh, you don't connect it, right? Remember, you want to look at multiplicity. At -1, it's a double root. So what happens at double root? Do we go through or do we do like a cave?
Oh, the cave.
Yes. So you have a little cave. Yes. And just go through that point. Yes, you got it. That's it. And draw that arrow. Let's go. Let's go, team. You got it. Does this make sense?
Yeah, and these questions are the same thing.
I think so. All you have to do is like you don't have to take pictures of your notes. I'll just check on your Desmos. I'm pretty sure that's the only difference. I think.
So this is going to be.
Okay. I think we have time to go through one more question. All right, this is a little bit complicated. Both are double roots, right? So it means what? Both have caves or both are going through the point?
I think both are going curves.
Yes, it's cave, right? Nice, nice,
Yeah.
nice. Yes. Mm-hmm. Oh, you have x at 3, right? So that's x at 1. No worries. Yes. Hey, Subin. Oh, remember it's negative, so it should go down, right? Yeah. Nice. Yeah, Subin, you're allowed to leave. Have you submitted your assignment? Or are you good with your assignment? Subin, you can chat me or come off mute. All right. Oh, remember it's a concave, right? Okay. Good job, Subin. I will look over your assignments. Lillian too, if you're done, you can leave. Class is technically over. All right. Ooh, wait. All right, Angela, you see, it's supposed to cave, right? It should cave at the point.
Yeah.
Yeah.
So it should be caving down.
Yes, because you need, as long as you have a cave, that's good. You just have to cave at the point. So it doesn't look like a cave. Can you make it look a little bit more like a cave? More like an upside down U at that point. So look like that. Boom.
Like this.
Oh, it's going up, right? Your point is here. Your point should be at the highest point. So it looks like a cave, right? Can you see on my hand? It should look like this.
So should we do this?
Give me a second. Let me grab a pen. I can draw my hand. Give me a second. Grab a pen. Do I have a pen? Oh, oh my goodness, Emily, you don't have a pen. All right, give me 1 second. Let me think where my pens are. Not in this room. Oh, JK. Okay, so our point Hopefully this works. So we have a point here, right? Can you see?
Yeah.
Oh, you can see? I can't see. All right. Oh my goodness. So we have a point right here, right? Can you see that point? This point, orange point?
Mhm.
So if I already have a point, like a curve like this, I need to curve at this point. So it should look like that.
Mhm.
You see that? So I curve at this point. Can you see?
I can't really see that much, but
All right.
so you're saying that it should be curving
Damn.
curving here.
Oh, here. No. Here. Let me try one more time. I don't have paper with me. That's probably why. All right, this might work. Give me a second. So we have a point right here. So this is what we have, right? We have a point.
Mhm.
Can you see? It's flipping. We have a point. So we want to curve at this point. So what I want to draw is, I want to draw like this. You see that?
Yeah.
So it should look like that.
Um, can you share your screen?
Okay.
Because I can't really see.
Sure. Can you unshare? All right. Can you see? So all
Yeah.
you're doing is that you have this, right? Right now, you have the point here, and you know it's looking like this. When it's a double root, you want to curve at the point, at this point.
Oh,
You want to curve. Yeah. Does that make sense?
yeah.
Cool. All right. I will unshare. Can you share your screen?
Yeah. So you want to do this.
Yes. Okay, but we're not drawing the arrow because we have to connect the points, right?
Yeah.
Cool. All right. So now we have this, and cool. We have it down. So can we try to reach to the other point? Try to connect them. Yeah. Oh, but not directly at the point because this other point is also a double, right?
Yes, sir. It should be curvy.
Yes, it should be curvy. All right, curves. Very good. No, not reach the point. Give me a second. Let me draw this out too so we can see.
Reaching the point.
So we have this. All right, cool. So before you go there, let's try to draw the curve until you hit Y. Can you draw the curve until it hits the Y axis?
Yeah.
Cool. Let's keep it there. All right. And so we know that it's going up. So it means how should our cave looks like? How should our cave look like at x equals -2? Should it cave downward or should it cave upward?
Upward.
Think again, because if we do caving upward, we have to create another cave to connect the dots, right? So it should cave downward, right?
Yeah.
So can you draw like the downward cave on -2 first? No. You're drawing the cave at -2, right? It's like what you have for 3.
Also, it should be like this.
Can you draw out first so I can see?
So,
No. Okay, cool. Can I share my screen?
yeah.
Cool. I know it's a little bit confusing. It might take a little bit of time to get used to, but here we go. All right, so this is, sorry, haven't shared my screen. There we go. So this is what we have, right? We have 2 points. 1 point here, another point here. So I already know that because it's a negative function, the end on the most right will go down. So we got this part done, right? And I also know that it has a multiplicity of 2, meaning it's a double root, right? So we have that cave. So I'm going to draw off the screen, not just draw the connecting in a different color. I'm going to have it reach to when we hit the y, right? And let's look at here at our x equals -2, right? Because if we have it like this, right, if we have it cave up, what would happen is to connect this end from that end, I'll have another cave, right, which is creating another cave, and that is not okay. So I know that, hey, I cannot do it upward, so I have it downward, right? So when I connect this end with this end, all I have to do is to extend this line. Do you see that? I'm not creating any new caves. Does that make sense?
Oh,
Kind of.
oh, that's how you're trying to undo it. I thought that it was someone else.
What is someone else?
I thought that I thought that the graphs were supposed to be like the ones that we were doing before.
Could you
Yeah,
repeat
that's
that?
what
It was a little bit muffled.
it's because I thought that the graphs were supposed to look like how we were doing it in the
Oh, like this?
yeah.
Okay, so this is when it's a cube, right? The solution
Yeah.
is like a 3. But because we have double roots for both, we have square and square, right? Remember how, like, to determine the number of solutions, we add the exponents together. So we have square and square, so it's 2 plus 2 equals 4. So we have an x to the 4th power. And remember last Tuesday when we were defining the shape? So x to
Yeah.
the 4th power should look like an m or a w, right? So w when it's positive, m when it's negative. And remember with this function, we have a negative function, right? So you see how that's why we have a m. Does that make sense?
Yeah.
But that was a good question. That was a great question. Now I see. So to tell whether we have a shape like this or a shape like a m or a w, all we have to do is to add the components, the exponents, right?
Mhm.
Does that make sense?
Yeah.
Cool. All
Yes.
right. I think this is all the time we have for today. But if you have more questions, feel free to email me. Or if you want, we can also schedule like an office hour tomorrow to go through this assignment or any of the previous assignments. Just let me know. Or you can just come on Thursday and we can get those questions cleared. But make sure that if you are still confused, try to watch a video to see if the video will answer your question, because on Thursday, we will have to work on something like this. We're adding on to what we've learned today and add new concept. So it might be a little bit difficult if you still have problems and questions on this assignment. Okay?
Yes.
Does that
Yes.
make sense?
Yeah. So on Thursday, are you gonna work with this again individually?
Yeah, so on Thursday, we're still working on polynomials. We're gonna do this thing called limits. It might be a little bit confusing at first, but what could also help is the video for assignment and notes 37. The video for that lesson is already uploaded. So if you want, you can watch the video and then you can email me asking questions if you have any things that are unclear about, or you can schedule an office meeting with me on Wednesday.
Yes. Yes. So could we schedule a meeting on Thursday?
You can schedule a meeting on Thursday too, or just come to my office hours. Do you have any free time between 10:30 in the morning to 12?
On Thursday. Yeah, I have time.
Can you tell me what time you have available so I can note?
Most likely 12.
So the time ends at 12. So I'm free from 10:30 to 12, right? You should have
10:30.
either block 3 or 4 free, right? Because you only take one Spanish class.
Yeah.
So which time do you have free? Do you have 10:30 to 11:20 free or 11:20 to 12 free?
At 11:20.
11:20 to 12 free?
Yeah.
Okay. So you can come to my office hour from 11:20 and we can go through assignment 37 together if you want. Do you have any more questions for this assignment because it's due today? Do you think you kind of get it, or what are parts that you're still like confused about?
I think for this assignment, I would be pretty much okay because you've basically explained all the different procedures and strategies to this. And
Mm-hmm.
I think on Thursday, I just want to like review the like new.
Mm-hmm. Yeah. Okay. So that could be helpful. But if you have like more questions popping up, let me know. If not, I'm grading your assignment tomorrow. So if I see that you're still confused, I'll let you know, and then we can go through those confusions on Thursday. Does that sound good?
Yes. So
Okay.
I come on your Zoom or
This Zoom. You use Miss Mac's Zoom. So just come to this room and you'll find me at 11:20.
okay. Thank you,
Yeah,
Miss.
of course. One more thing. So if I don't see you at 11:20, is it okay if I invite you? Just like a
Yeah.
reminder. Sounds good?
Just invite me.
Okay. All right. Sounds good. Thank you for a great session, Angela.
You're welcome. Bye.
Yeah. Bye.